Hi, welcome to tutorial 1.6 part 4. This is on the last one on dimensional analysis, and I'm just calling it applications. And you'll see if you play with the quiz a little bit, there are actually 4 separate problems that are going to be asked of you. One of them is just to figure out the volume of a box like this. And then later on, somewhere they're randomly generated, you'll be asked to find the surface area of a box. And the other one will ask the same 2 questions, the volume and the surface area of a cylinder. And again, the idea is to kind of give you different units and make sure you can manage the kind of unit conversions and the math at the same time. So let's look at this first one. It says the box has a length, width, and height given in centimeters, and I would like to know the volume in liters. Well, I'll multiply length, width, and height to get the volume in cubic centimeters, and then I'll have to convert that into cubic decimeters because that's what a liter is. It's a cubic decimeter. I remember there's 10 centimeters in a decimeter, so I know that there's 1,000 cubic centimeters per cubic decimeter. So those are the numbers that I'll need. Let's actually walk through it. Length times width times height is the volume of this box. All the dimensions are given in centimeters. I multiply them out. I end up with 4.07 times 10 to the third. I now have to convert that into cubic decimeters. So I remember, I say, oh, that's right, a decimeter is 10 centimeters, so a decimeter cube must be 1,000 cubic centimeters. And I have the answer from the previous calculation, 4.07 times 10 to the third. I say, do I divide or multiply by 1,000? I let the units guide me. 1,000 cubic centimeters per decimeter cube, so therefore I have less cubic decimeters, of course, than cubic centimeters, so I divide by 1,000. I have the answer in decimeter cubed, and this is somewhat trivial since you perhaps just remember that a decimeter cubed is a liter. You already know the answer in liters by having the decimeter cubed or formally write it out. And the answer is 4.07 liters. Okay, so that is the volume. Let's look at a surface area of a box like this. So it's the same kind of question in the sense that we're looking at some dimensions and at the end converting them into a different unit, but this time we're asked for the surface area. So let's make sure we get how to do that first. To get the area, the surface area of this box, I can say it's going to have this length times width will be the area of this front face. But there are 2 such surfaces. There's one in the back that's not shown, so I'll have to double that. How about this kind of front piece here? That would be the width times the height, and I'd have to double that as well. And finally, the top and the bottom piece is the length times the width. So those are the 6 surfaces that I have to find the total area of. Here it is worked out. It's all written out in the formula here. Each of the 3 faces are shown, the length times width of the one, length times height, and the width times height. I find at least that I need the diagram in front of me to kind of make sure I'm not multiplying the wrong numbers here. But once you have it, remember you have to double it all because there's 2 of each of these surfaces in the final box. The rest is just putting in the numbers, that is making sure you get the length and the width and the heights, etc. in the right place in your little expression. And I'm not looking too carefully here at significant figures. I'm just trying to understand the basic problem solving mode without over concern. So we end up here is what? A area in centimeters squared. We round it to 2.03 times 10 to the third centimeter squares. And now I need to convert that finally into the unit that's asked for, which is the millimeter square. There's going to be more millimeters squared than centimeters squared. A centimeter is 10 millimeters, so a centimeter square has 100 millimeter squares in it. So my result from the previous calculation, 2.03 times 10 to the third centimeter squares times 100 millimeter squares per centimeter squared. 3 plus 2 gives me 10 to the 5th as the power of 10 to go with the 2.03 millimeter squares. Hopefully that was okay. So now let's have a look at the cylinder, which is a little harder for people just because they're less familiar with the formula for it. The cylinder shown has a diameter given of 960 in centimeters and a height of 1440. Question, what's the volume? You can remember the formula for the volume of a cylinder, or just think about it for a minute. A cylinder is made of a whole bunch of these discs, these kind of circular disc areas stacked on top of each other. So it's just the area of a disc times height, or pi r squared times that height. That's the formula. Here it is written out. So it's pi r squared, the area of that disk at the top. The number of disks is going to be given by the height. I find the radius. It's just half of the diameter. We were given a diameter of 960, so half of that is 480. We square it, multiply by the height, and our final answer for the volume is 1.04 times 10 to the 9th cubic centimeters. Again, now we get to the unit conversion part. We said, well, we don't want to know that. We want to actually know what it is in decimeter cubed. So I have to do the same thing we've done before lots of times. 10 centimeters per decimeter, make a cube out of those. So a cubic decimeter is 1,000 cubic centimeters. Again, I know I have to divide because I want to know how many of the larger cubes there are in this number of cubic centimeters. The units guide me to make sure I don't make a mistake. And I end up with 9 minus 3 powers of 10, or 1.04 times 10 to the 6th cubic decimeters. It's quite a few, over 1 million cubic decimeters of volume. The last one is the hardest because it asks for the surface area. And what's hard here is just that it's just a geometry thing that might trip you up for a moment. Perhaps you're not clear how to find the surface area. So let's think about this. And you kind of have to see this in your mind's eye, and I'll kind of move the cursor slowly enough so you see it. First of all, you need to know the area of this top disk. And there'll be two of those, the top one and the bottom. And that's straightforward. That's pi r squared, but there's two of them. How do you get the area of that kind of the outside part of the cylinder itself? Here you got to think about this. Imagine taking the cylinder apart and rolling it out so that you could see that surface. How long of roll would you have? Well, the roll would be the distance around the circle, which is 2 pi r, the circumference of that circle. So how long that roll would be is 2 pi r, and then the height of it, of course, is just given as the height. Alrighty, that might take you a little bit to think about. So kind of maybe draw a picture if you need it. I didn't take the time to draw one here, but let's get the answer. So pi r squared is the area of that disk at the top, but there's two of them, one at the top, one at the bottom. That's why there's a 2 here. This is the length. If you would roll out that kind of take off that surface of the cylinder, roll it out, its length would be 2 pi r, and then its height would be h. So that gives you the other area of that surface. All right, then just add up those two, plug in the numbers, and we end up with the area in centimeter squares. We're not asked for centimeter squares, but we're asked for, I don't remember, decimeter squares. So once again, 10 centimeters in a decimeter, square them, and 100 centimeter squares are in a decimeter square. So we have to divide the number of square centimeters we have by 100, and we end up with our answer of 1.26 times 10 to the 4th. Okay, so, and I'm going through this. I'm not sure exactly how this feels to you. My experience is that most students can kind of follow it readily enough, but when they go to do it themselves, again, they kind of make little errors one way or the other. And so you really should spend some time with the quiz. And just in terms of encouragement, you might say, well, gee, is this really going to come up in the chemistry class? I feel like I'm doing geometry here. We use some basic geometry like this in order to, in the lab, determine the size of molecules and atoms. So we do use this kind of analysis. So try to become pretty good at it. You'll see in this couple labs that follow, you won't be able to get through the calculations to get that dimension of an atom or molecule without it. So it is worth practicing. All right, good luck with this. I'm sure there'll be lots of questions, and we will address them in class. All right, I'll see you there. Bye. Thanks.